We're moving to green ammonia, carbon credits in agriculture, a first look with Ian Clifford and André Mech. Ian and André come to us as CEO of FuelPositive, and André is the advisor on carbon credits and emissions reductions for FuelPositive. Ian spent his career combining his love of environmentalism, technology, and marketing. And André has worked in the emissions reduction space for more than 20 years, assessing emission profiles of hundreds of transportation and renewable energy companies. So thank you, and I'm looking forward to hearing what you have to share with us.
Ian, I think you're on mute.
Great. Sorry, can you hear me now? Can you hear me? Great. And can you see the presentation?
Yes,
Okay.
we can.
And is it moving? Whoops. And then the trick here, is it moving? Did it move forward for you?
We are on overview.
Okay. And is it moving to the next slide or not?
No.
Okay,
No.
I'm just going to stop sharing. Sorry, this sometimes happens. This is a little weird. Let me see if that works. And how about that?
Still on the first slide. Maybe if you hard move it on the left-hand side to number 2.
Yeah, I'm going to try this. Let me just try it a little bit. Sorry about that. Sometimes happens.
Hello, Ian.
I'm here.
Can you hear me?
Loud and clear, yes.
Okay.
Can you see this now?
Yeah.
There we
Yeah.
go. Yes.
There we go. Okay, excellent. Good.
We're
Sorry
good.
about that.
Hi,
Good.
Peter.
Hello, hello.
Hello, hello. So,
Okay, Ian and André, you
I'm gonna
guys
take-
are
I'm going to take
on.
our
Hi.
entire 20 minutes and read the disclaimer to everybody. So, so again, thanks so much, everybody, for giving us the time today to present our new company and our objectives.
oh, this is very interesting.
Thank you, Hazel.
Yeah.
As a brief introduction, we're a company dedicated to acquiring and commercializing clean, sustainable, and economically viable solutions that can be deployed in the short term. So this is not technology that is decades.
Right. I mean, this
coming.
is my whole thing. You know, we don't need any new technology, no more huffing and puffing, you know, with research. We've got everything we need. We just scale it up.
Exactly. And
Yeah.
the words out of Greta Thunberg's mouth in that regard. Exactly. It's so true. Our initial technology is a system for producing green ammonia.
You want me to mute now?
Oh, sure. I will
Sure,
just
yeah.
and then we can take all the questions, of course, and comments. So this is a system to produce green ammonia. And we're in the demonstration prototype phase now, and we'll talk about that in a moment. And our system is designed to produce green ammonia on site for a wide variety of uses, especially carbon-free fertilizers and fuel, which tie back into what Keegan was saying as well. So for the past 100 years, ammonia has been produced in massive refineries using an invention called the Haber-Bosch process. And that was hailed as one of the most important inventions of the 20th century. That process saved the world from famine by making it possible to produce ammonia, most of which is used for fertilizer at a mass scale. And today, about 200 million tons of ammonia are used annually around the world, with about 80% of that being utilized as fertilizer. It's also used in many other industries, including textiles and mining, to name but a few. Surprisingly, a really small number of massive refineries provide all the ammonia that's used around the world. But here's the problem. The Haber-Bosch system used to produce traditional ammonia, which is also referred to as gray ammonia, is one of the most polluting manufacturing processes on the planet because it uses fossil fuels as the core key input. In fact, to make 1 ton of gray or traditional ammonia, the ammonia industry emits about 3 tons of carbon dioxide into the atmosphere. And the supply chain is wildly unreliable. And prices have skyrocketed in recent months and years due mainly to fossil fuel input costs and supply. Intense weather systems and global conflicts, of course, have added to this significant variability and uncertainty. Many farmers, for instance, are telling us they're on the brink of bankruptcy because of their out-of-control fertilizer costs. So this is a very, very present and relevant issue today. The paradox is that we still need ammonia as much as we ever did, primarily for food security, but we absolutely can't continue to produce it the way we have been doing it because it's too polluting, and it's become both unaffordable and unreliable. This slide shows you the traditional gray ammonia supply chain with the refinery on the left. And you can see that once it's produced, the ammonia is moved through the supply chain and stored in a series of storage facilities as it makes its way to the end user, in this case, a farm, on the right side of the slide. And you just have to look at how complicated the supply chain is and how many transfer points it involves, with each transfer providing opportunities for greenhouse gas emissions, delays, and inefficiency. And there are several storage, loading, and unloading stops along the way, from the refinery to regional depots to more local depots, and finally to the ultimate destination. And on top of the emissions at transfer sites, you also need to consider the fossil fuels burned by the vehicles transporting the ammonia to each step along the way. It's critical to note that the traditional ammonia supply chain has a massive carbon footprint. So enter our solution. And this shows what our patent pending fuel positive system consists of. You can see it includes a nitrogen generator to produce nitrogen from air, an electrolyzer to produce hydrogen from water, and a novel patent pending ammonia synthesis converter to produce ammonia from the nitrogen and hydrogen. Our initial intellectual property is centered around the converter technology. And unlike traditional gray ammonia, our system utilizes a sustainable source of electricity, such as solar, wind, or hydro. And that's why we're able to make green ammonia with no CO2 emissions. We call this a plant in a box because the systems are modular and fully portable. They're being built to fit within standard 20 and 40-foot shipping containers, which means that they can easily be shipped directly to the location where the green ammonia is needed. And their output can be scaled up or down depending on end user requirements. This slide shows what a farm would look like utilizing our system. You can see that water and air go into the fuel positive container-sized production unit that's powered by sustainable electricity sources. In this case, some windmills and solar cells. Some farmers already have renewables helping to power their farms. Others will need to invest, and we're helping them determine the source what they need for the most stable and affordable supply of green ammonia on their farms. The farm will then use our green ammonia as fertilizer, which is injected into the soil, ultimately by a green ammonia fueled tractor. It can also be used as a fertilizer in the farmer's greenhouses. And our green ammonia can be used as a fuel for grain drying or to power any other farm systems the farmer uses, including generators for backup power. Once a farmer has the sustainable electricity source on farm, their supply of green ammonia will be steady, with no price fluctuations year after year. And that independence and security to the end user is a driving force behind our system and our offering. And I'll hand this slide over to André.
Thanks, Ian. So this slide shows our forecasting and costing model. As you can see, the cost to produce green ammonia is well below the average price being paid for traditional ammonia in Manitoba, Canada, which we've set at $900 per ton based on our conversations with Manitoba farmers. They've told us the cost of traditional gray ammonia has risen from $600 per ton to $1,200 per ton over 6 months earlier this year. And right now, because of global conflict, it's over $2,400 per ton. Our cost to produce the same amount of green ammonia using our system on a farmer's land would cost about $560 per ton. In this chart, we have shown current costs going out to the future with forecasted costs based on some basic assumptions. The chart focuses on operating expenses, with FuelPositive's green ammonia at the bottom in green, just above that, gray ammonia minimum costs, then gray ammonia average costs, and finally gray ammonia maximum costs. Keeping in mind that the primary cost is the price of electricity to run the system, which varies from place to place and time to time. As time moves on, the cost of solar electricity is expected to decrease dramatically, and so does the cost of ammonia production using our system. Since renewable electricity plays such a large role in our system, it's important to understand how many solar panels our system would require to run the system. The image on the right provides a simple visual which illustrates the size of the solar array in comparison to a 1,800-acre farm in Manitoba. A 1 megawatt solar array, which is what this farm would require for the ammonia to be produced, occupies 1.5 acres. It is a fraction of a percent of the entire farm, so it's not really a problem. We're planning for our first demonstration installations of our phase 2 systems to be in agricultural settings in 2022. We're finalizing plans for the first installation, and that farm will be using the green ammonia as a low-cost fertilizer and fossil fuel replacement for grain drying and farm equipment such as tractors and generators. We're working directly with our first demonstration project farmer and the next few follow-on farmers. FuelPositive also expects to generate significant revenue from carbon credits that we generate as our carbon-free ammonia is produced. This represents one of the first times ammonia and carbon credits would appear on the same statement, given the huge carbon footprint of current ammonia production. Massive carbon footprint of current ammonia production. We plan to generate carbon credits for voluntary and compliance markets that are active in areas where our production systems are utilized. Our production system is so efficient and our product is so energy dense that for each ton of green ammonia produced as a fertilizer, it is expected that we will reduce carbon emissions by an average of 3 tons of carbon dioxide equivalents. The revenue derived from carbon credits and emission reductions will fund future growth and investment in new carbon-conscious technologies at FuelPositive. And at this point, I'll hand over to Ian.
Thanks for that, André. So there you have it. So with the skills and broad reach of our team and consultants that we're assembling, we expect to make an impact in many vital and emerging markets around the world. The interest coming from every part of the world is extraordinary. We're overwhelmed by the level of interest in this decentralized, efficient, and independent model, if you will. Just solving the helping solve huge emission problems within agriculture alone would have such a positive effect globally. It's really hard to measure today, but we're trying to measure it and put it in context. And providing users of ammonia around the world with stability and predictability in some key aspects of their operations is a priority for FuelPositive, and it resonates, as I said, profoundly with our audience. Just really quickly, we are a public company, so we're very, very pleased with the performance of our stock over the last year. And I'm also really happy we have a lot of new institutional shareholders with very large environmental portfolios taking very meaningful positions in the stock. So that's been a real a boost of confidence to us as we move forward. We've got great advisors on the financial market side of the equation, and things are moving steadily forward with consistency and a real genuine attempt to, to underpromise and overdeliver in every aspect of our business. So we've been very, very successful in that context as well. So that's it. We're happy if there's time to take some questions, but wanted to give an overview of what we're about. So hand it back to you, Julie.
Thanks, Ian and Andre. We do have a couple minutes left and a few questions that have come in. First of all, can you speak about the waste products of your process?
Well, it's interesting. They're not waste products. They're actually byproducts. So one of the components that is released or reformed in the process is oxygen, is pure oxygen. So there's a lot of discussion now about how we can utilize oxygen on farms specifically in different applications. So that's a positive byproduct. The neat thing about our system is the catalysts and the materials that are utilized in the conversion process are not rare elements. They're readily available. It's over a 10 to 15 year cycle before any of those components need to be renewed at all in the process. So it's a highly robust system. It's also standalone in the sense that the expectation is that the farmer or end user will have very little interaction with the system. It's fully monitored and controlled remotely. There's nothing for the farmer to do other than benefit from the output of the system. So very, very intelligent engineering in terms of management. The other aspects, of course, are the on-farm aspects. So we've created a carbon-free source of ammonia. Then the issue is what happens to emissions on-farm. So we're spending a lot of time looking at nitrous oxide, nitrate type emissions on-farm. Certainly as we look at combustion of NH3 as well. So we have a very significant program underway at the company to understand those emissions and reduce emissions dramatically. Also in the application of and utilization of anhydrous ammonia and other forms of nitrogen fertilizers.
That's great. Ian and Andre, you have other questions that I hope maybe you can get to in the Q&A just by typing answers, so we can stay on time and move on to our next segment.
Thank you.
Thanks, you guys.